In this problem, we're going to compute f prime, the derivative, but we're going to use the limit definition of the derivative. So before we get started, let's write that down. Limit h approaches 0, fx plus h minus fx divided by h. All right, first thing, we have f of x. We need to find f of x plus h. So we'll do that here. So I'm using f of x, and wherever I see x, it appears one place. I'm replacing it by x plus h. In this example, you don't need parentheses around x plus h. You could put them in, but it's not necessary. Generally, it's probably a good strategy to do that. Now, in this problem, there's nothing else to simplify here. So we can go ahead and plug this in. Lim h approaches 0. 4 square root x plus h minus 8 minus regular f of x, which is written again right there, 4 square root x minus 8. All of that over h. Okay, what to do next? There is a 4 and a 4. We could factor out these 4s here. I could write the over h right there. And we're left with x plus h minus 8 square root minus square root x minus 8. Okay. So from here, what to do next? This next step is not obvious at all. We're going to use what are called conjugates. It's J-U-G. Conjugates. And if you have a minus b, the conjugate is a plus b. And if you started with a plus b, the conjugate's a minus b. So it's the same thing. The difference is there's a positive and a negative sign. And what is useful with conjugates, when you multiply them, when I FOIL these out, I get a squared. Now, that's a times a. Outside, ab. Inside is negative ab. And those cancel each other out. So ab minus ab cancels out to 0. So the last terms multiplied, negative b times b is negative b squared. So when you multiply conjugates, a minus b times a plus b, you get a squared minus b squared. This is also known as difference of squares. All right, we're going to use this fact that when you multiply them, each term basically gets squared. So what we're going to do, we're going to multiply by the conjugate of what I just circled, the square root minus the other square root. So what's the conjugate of this? Square root x plus h minus 8 plus, so it's the two square roots added together. But of course you can't just multiply by anything you want. You can only multiply by 1. So we're going to multiply by this very special version of 1. And we multiply this here. We're multiplying numerator times numerator. When we multiply these together, it's the first term times the first term. And notice they're exactly the same. So when we multiply those two together, we get the square root to cancel. Now we multiply the second two terms together, the square root cancels. One of them is negative, so you get negative x minus 8. The denominator, there's nothing to do. You could have written this fraction over 1. So you can see you're multiplying 1 by that denominator, so it's not going to change. And the denominator is x plus h minus 8 plus square root x minus 8. Copy everything else down. All right, what to do next? We are getting there. There needs to be cancellation at this step. So I'm going to go back to blue here. We have, I'll cancel an orange. X minus x cancels. And the negative 8 minus negative 8, or negative 8 plus 8 cancels. And what we're left with is just h. So finally here, we have divided by h, multiplied by h. Those two cancel out. And remember, whenever you're doing a difference quotient, the entire goal, the algebraic goal, is to get rid of or cancel that h in the denominator. So we have finally canceled the h on this last step. And we're ready to take the limit. So I'll just rewrite it one last time. So it's 4 over square root x plus h minus 8 plus square root x minus 8. And from here, you just plug in 0 because you're not going to be dividing by 0 anymore for h. Now you're only plugging in 0 for h. X stays as it is. So x plus 0 is in for h, so it's just x plus 0 minus 8, or x minus 8, plus square root x minus 8. So from here, there's 2 square roots added together, so it's 2 square root x minus 8 over 4, and that can reduce to 2 over square root x minus 8. All right, that is our derivative using the definition.